All right, we've done it. Okay, so what do you guys get for the rest of these? What do you get when you plugged in -1 squared? What do you get? Yep, -1 all squared. Yeah, it should be +1 because -1 times itself. You got negatives here. You shouldn't have. You didn't put parentheses, and so the calculator got confused. So it should be 1. Okay, hurry. 0 squared. What'd you get? It should have gotten 0. 1 squared is 1 times itself, which is 1. 2 squared is 2 times 2, which is 4. Okay, cool. So then you fill out your little table, and then these tell you the x and y coordinates, remember? So like, for example, -1, 1 would look like 1 to the left and 1 up. 0, 0 would just mean right at the center. 1, 1 would mean 1 over, 1 up. This too fast, or I think you guys understand this. Okay, and then 2, 4 means 2 over, up 4. Okay, and then this is like a whole function defined everywhere, so you can connect these guys. And you should get that U shape that looks like that. Whoa, awesome. So remember when we did that Desmos project, you guys could only use lines because that's the only thing we knew. Now you know this cool little curve, which comes from the function x squared. Kind of interesting. And this is what we'll be doing basically for the rest of the year, I think, is graphing this type of thing. It's called a parabola, by the way. Okay, then did you guys remember about domain? Yeah, I'm guessing people forgot that. But domain means what are you allowed to plug into x squared? Like, are there any numbers that break some rules or are undefined when you square them? And the answer should be no. So do you guys remember what it's like, how you say every number? You're a beast. Yeah, -infinity to infinity, like that, in parentheses. Then, did you remember about the range?
Like something to infinity.
Yeah, the range is all the y values that come out of this function. So looking at the graph, yeah, what were you gonna say? Yeah, except you got to make sure you do it bottom to top. So it should be 0 to infinity. And then one small thing, don't forget, in this case, we actually do touch 0. Like there's a point that touches right at 0. So from bottom to top, we touch 0. That would be a square bracket 0. Oh yeah, we haven't really looked at that much. But yeah, square bracket 0, and then it never stops touching. Like the top of the function doesn't exist. It goes off to infinity. So 0 to infinity, and then infinities always have round brackets. Cool. Okay.
Can you explain the brackets again?
Yeah, the brackets, since it does touch 0, like it doesn't just get really close to it, it actually touches. It includes it, so that's a square bracket. And then if there's something that it gets close to but never touches, like for example, infinity isn't an actual number, you can just get closer and closer and closer and closer to infinity. So that's a round. Yay. Okay, good job. All right, and y-intercepts, hopefully you remember that's just wherever you cross the y-axis, so where would that be? Yeah, 0. Some teachers like the whole coordinate, like the point 0, 0, but I don't care either way. The y-intercept I just wrote is 0. Okay, cool. So there you go. That's what we'll be doing the rest of this time, except we'll learn some like shortcuts and stuff. Today, though, I think we're just using tables, but later on we'll learn shortcuts on how to like get this shape without really thinking that hard or having to plug in a bunch of numbers. But first, let's learn a bunch of vocab because you guys are just brand new to this. So first of all, when I say a quadratic function, like we'll be graphing a bunch of quadratic functions, hopefully you remember that quadratics is just any polynomial that has a highest exponent of 2, a degree of 2. So that's a 2. Okay. So quadratic functions are anything that looks, I don't know, x squared plus 3x plus 7. That's 1. Just x squared is 1. -7x squared plus 2 is 1. Anything that just like the highest exponent is 2, those are all examples. Okay. The shape of this U shape is called a parabola. I don't have much else to say about that. That's just called a parabola. Actually, I do have much else to say about it. You might have heard of like parabolic mics or parabolic satellite dishes or whatever. That's because they have the shape of a parabola. Okay, the blank of a parabola at its highest or lowest point. Oh, that's called the vertex. This point right here. The vertex of a parabola is its highest or lowest point. So if I make a quick example, this would be the vertex. Or if the parabola opens down like this, then that's the vertex. Okay, and then the last one is the axis of symmetry. This is like where the parabola is cut in half, basically. The axis, that's an A, of symmetry. It's a vertical line that divides the parabola into two symmetric parts. So like in this case, it would be like this. Boop, 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 boop. Oh, good lord. What are you doing? Hey, come on back, please. Children. Okay. So hopefully all of these make sense. The axis of symmetry, like I just said, here's an arbitrary parabola. It's the line that cuts it in half, like symmetrically. So this line is the axis of symmetry. That's not a very good picture, but you'll see what I mean when we do these. Okay, so first thing, pretty easy. Identify the vertex and axis of symmetry of the following parabola. Okay, vertex, like I said, is just this point right here. Okay, so that vertex would be the point 2, comma, -3. 2 on the x, -3 on the y. That's it for that. And then the axis of symmetry is a whole line. It's this line. Boop, 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 that. So yeah, that's the line 2, but if you just say 2, I could say, well, what 2? This 2 or this 2? So do you guys remember how to say this line? No. You remember?
Question, why would it be square brackets?
No, these are points. This is a point. So those never have square brackets. When we're talking about intervals, like from what number to what number, then you're talking about square or round brackets. That's a good question. But yeah, this is just a point, so it's always round brackets. And then Dylan Bryant, I heard you say it. How do you say this line? No. Yeah, x equals 2. It's x equals 2 because it's the line on the x axis right at 2. So even though it's weird, even though it's going up and down, it's like the opposite of what you'd think, but yeah, it's x equals 2. And that's always going to be the case. It's always going to be right on the vertex. Okay, so this one, the vertex would be, you tell me. Nice. So -3, comma, +7. Oh my God. Keep getting messages. Okay, and then the axis of symmetry, again, it's right on the vertex. So this would be what line? Nice, nice, nice. X equals -3. See, it should always match the vertex. Okay, then, well, are there any questions on that? That's just pretty straightforward, like you understand the vocab. Okay, cool. All right, then the next part, I have set up, oh, I forgot to set it. Okay, give me a sec. I go to desmos.com, www.desmos.com. Yeah, I don't understand why it's just a graphic. It like graphs things for you. Everyone says, "Oh man, Desmos is the worst."
Oh man, that's
No, I hear that from everybody, not just you. But it just graphs things for you. It's a nice little tool. All right, and it says, watch Mr. Cordero mess with sliders for Desmos for this function while comparing the parent function x squared. Okay, so let me graph that as well. So purple is just x squared straight up, the most basic quadratic function you can get. The most basic parabola is this purple. Here, I'm messing with it a little bit. I'm multiplying it by a number. Let's see what that does. So what's the first question? As the A value changes, what changes in the graph? Okay, let's change this. Look at how the red compares to the purple. What the heck, what the heck, what the heck? Oh, whoa, crazy. All right, so what's changing in the red graph compared to the purple graph as I mess with this number in front? Yeah, like it's, yeah, the width of it, or the steepness of it, or whatever. So yeah, that's a good way to say it. The width of it. Or you could say, or width, or steepness. Or what did you say, John? Like bigger or smaller? Yeah, any of those are fine. Okay, now compare positive A's to negative A's. So watch this, you guys. Watch this. These are all positive A's. Okay, all positive, all positive. Okay, now compare that to negative A values. Oh, whoa. Here's all negative values. So what's the difference between the negative values and the positive values? Yeah, exactly. Which way it opens. The parabola will open up if it's positive and down if it's negative. Cool. So what happens if the parabola of A is positive? The parabola will open up. And if it's negative, it'll open down. Nice. All right, compare the graphs of ax squared and x when a is bigger than 1 and when it's between 0 and 1. Okay, so what that means is, all right, here's when they both match. Purple and red are exactly the same when a is 1. Okay, obviously, because if I have 1x squared, that's the same thing as x squared. Okay, but what if I have like 2x squared or 3x squared? If this is bigger than 1, then how does the red compare with the purple? It's like smaller, it's like closer together. It's, how do you say, like narrower, I guess. It's like more intense, the curve. These are all good ways to think about it. You guys said smaller. I don't want to say smaller because it's like same, more narrow. Yeah, okay. So compare the graphs of this one. Ax squared is more narrow. And then you can probably guess what's going to happen between 0 and 1. If you have like a 1/2 or something in there, you could probably guess, but let's check when you guys are done writing. Okay, let's check. If I have like a 1/2 in there, or like 0.1, 0.3, what's the how do you compare red to purple? Yeah, the red one's a lot wider. It takes a lot longer to get steep because this number is like smaller. It's like a 1/10. But it takes longer to get it as steep. It takes longer to get to the higher number. Nice. Okay, that should make sense, I hope. If not, you should go home and think about it. That's good for your education. So we said the red graph will be wider. That means ax squared will be wider. Or is wider, maybe. Okay, there you go. Then it says graph the following parabolas and identify all this stuff. Whether it opens up or down. Okay, so this is just graphing. So plug all these into here, see what shape you get. So if you need a reminder of how that goes, you take each of these, you replace the x with it, and you see what y you get. So like for example, f of -2 would be 2 times, here's me plugging in -2, all squared. okay? And then you find out what that is, either like in your brain or with your calculator. But I think in this particular case where it's like small numbers, it's not that hard to do it by yourself. So if you do this in your brain, you're like, okay, PEMDAS says to do the exponent first. So what's -2 all squared? No, oh, that's the final answer, yeah. But -2 squared just by itself, -2 squared, what's that? Okay, and then you multiply that by 2, and you get the 8 that John. Okay, so this will be +8. All right. What's up? Somebody say what?
Because -2 times -2 is 4.
Nice.
4.
No. Yeah, if you get negative times negative, that's positive. This is +4. This would be 2 times +4. Which is 8. That's it.
And do the exponent.
Yeah, because of PEMDAS. So yeah, 8 is the correct thing. Okay, do the same thing with -1, 0, and 1 and 2. Let's go fast through this because this shouldn't be like a super hard like thing. How do I do this? You just plug the numbers in. So now I'm plugging in -1. 2 times -1 squared is equal to, well, -1 all squared would be -1 times -1. What's that? Just to make sure.
-1.
No. Yeah, +1. Okay, 2 times, because negative times a negative is positive. So 2 times 1 now is therefore 2. So that's a 2 right here. The 0 one should be real nice. So here's me separating all my work. Okay, 0 squared, what's that? Nice, and then times 2 is also 0. So 0, 0. And then, well, let's learn. I could show you a pattern, but I'll let you guys figure it out. 2 times 1 now, all squared. 1 squared, what's that? Nice, and then times 2 is 2. So this is 2. And then 2 would be 2 times 2 all squared. 2 squared is 4 times another 2 is 8. So 2, 8. Again, you could have done all of these in your calculator if you wanted, but I think it's just easier to do them in your mind's eye. All right, cool. Notice it's symmetrical. Boop, boop, boop. That should make sense. Okay, now we graph these, or like we plot all those points. So -2, 8. -1, 2, -1, 2. 0, 0. 1, 2. And 2, 8. Okay, and okay, you know you did it right because you got a parabola, of course. You just connect all these guys. And you get a really like steep, like narrow parabola. Which should make sense because of what we just talked about. If this is bigger than 1, then it'll be steeper than your average parabola. Like your most basic parabola. All right. You guys remember the vertex? Where's the vertex? Nice, that would just be this point. Which is 0, 0. The axis of symmetry is what? Nice. That's this line that cuts it in half. So x equals 0. And then it opens upwards is all this one. Okay. And you could have guessed that because this is positive, like we just talked about. Okay, I think the rest of this is just practice, and then there's one like application problem. Diagram below. Oh yeah, 2 application problems which are basically the same thing. So see if you can do the rest of these. If I get a lot of questions on this one, then I'll tell you what it means, but it's not that hard. It just has you counting how deep is it, how wide is it. All right, try. For this one, it's okay that you'll get a lot of decimals. Yeah, decimals or fractions or whatever. decimals okay? Yes.